In today's video, I will show you LCMS, how they work together or how they connect each other. So for the beginner, you can see here, this is the bulb of LC, and you can add sample by that bulb, and you can do that by manually or automatically. And here we add mobile phase, and for an example you can use H2O or CH3OH as a mobile phase, and they are polar. So by doing that, that mobile phase and sample will go through that column. So this is mobile phase plus sample, and it will go through that column, and column is a stationary phase, and this column is made by like C18, C8 or C4, any kind of compound, and these are non-polar. So here we using polar and non-polar as a mobile phase and a stationary phase. So we are doing here reverse phase chromatography, and after doing that, this sample and mobile phase will go through that column, and it will go through that interface named ESI. So this is the interface between LC and mass. So this portion is known as LC, and other this portion will known as MS. So if I just explain that ESI in details like that, so first it will produce a large droplet of sample and mobile phase. So this droplet is coated by the sample, okay, and this portion we will use 3 to 5 kilovolts, and it will evaporate that uh, solvent layer of that sample, and it will make smaller droplets. So here we do evaporate the solvent, not sample, solvent, and also it is called desolvation, okay. And like your sample is like M, and this sample is coated by like ACE. This is acidic solvent, I think, and it will produce MAs plus. So at the end we'll get that ESI like M plus ACE plus, like that, and also it can produce 2A's here, or it also produce Na. So actually you do not know what is in your sample. So there may be H plus or sodium or another cation, there may be present. So after doing that ESI, we will find that ion, for example, and after that ESI we will go through that ion transfer tube. So what will happen here, we are producing ESI plus charge, and we will add here negative charge. So this plus and minus will attract, and it will transfer this tube, and after transferring that it will go through that quadruple. So there are varieties of quadruple used in LCMS, like triple quadruple, QQQ, or Q-top, or you can also use orbitrap. So these last two on orbitrap, okay, so these last two are used for like untargeted analysis, like high resolution HR, high resolution, or untargeted analysis. but I will discuss about that simple one. It is used for low resolution and for targeted analysis. So in that quadruple there are three positions like q1, q2 and q3. So q1 will select that ion, parent ion, you may call it parent ion. And what is the parent ion? Parent ion is that m plus h. Okay, it will select by the q1. And the q2, the device input that nitrogen gas and it make collision here, and it will fragment that parent ion. Fragment, it will do fragment, and it will produce product ion. Then after q2 it will go through the q3, and this is the uh, section we will specify that ion by mg. That's mean we will select a specific ion because this is a targeted analysis, and it's like that. If I want 140 mass by ratio, this 140 mass will go through that, others will not go through, like 139 or 141, they are not going to that portion q3. Okay, so after doing that q3 or mass specific portion, it will go through the detector, and detector will amplify their signal and produce that things. This is called mass chromatogram. So if you do not see this before, this is really tough things for you. So this is mass chromatogram. In so you can suppose it as a graph, which y-axis is intensity and x-axis is retention time. So what is that actually things? So I can explain it in easy way, I think, by adding a another image here, I think, and this is like that. So I am showing you that mass chromatogram in another picture. So this is like that. So like so in y-axis you will get intensity here, intensity. Okay, so suppose this peak has the intensity like 195.05. Okay, this peak's intensity is 325.07. So, and this is a specific retention time, this is like 2.7 retention time, and you click on that specific 195. Okay, when you click on that, it will pop up a mass spectrum. So I need to add another picture here, and I need to show you how it do their job. So this is you will get from 195 you will get a mass spectrum here. So suppose this peak has a intensity 195.05. Okay, and this is that mg value of that compound. So from clicking on that, you will get that mass spectrum, which is intensity is 195 and the mass value is like 50.3. So you will get mg value from there, and you also confirm that this is the dat fix. So you may question that what are other peak. So this may be their isotope of that compound. Okay, and you also ask what is that compound. So suppose this intensity is 275.05. So this peaks is actually other compound. So at the same retention time, you can see here 2.5 2.7, you will get two compound 195. That this one is known to you, but this one is not known to you. Actually this thing happens for that high resolution, high, high, high resolution. And what we'll next to do is just keep that mg and produce that things a specific amount of that product, and it will go through that NMR, and we will find out the structure of that compound. So in peak analysis of mass spectroscopy, you can find mg here, you can see, and for unknown compound you will get just a specific mg here, but you will not confirm that this is the that compound or this is the that compound. So further proceed you need to do is just make that compound a specific amount for, like, you can do that NMR, you can run that NMR, and you will get the picture of that compound in the NMR, and you can analyze that what amount of atom or other things is there, and you can deduce that the structure of that compound. So for my aspect, I think mass spectroscopy is not full, so you need to do more things to get a specific compound or something like that. So this is for that. I think LCMS, you understand how it works and how it connects. ESI is the interface that connects LC and MS. So it will produce a mass spectrum and you can analyze that. And also after that, if you want to find that specific peak, you can also run that NMR. So this is for the video LCMS. I think you better understand now, and see you.